Now let's move to our second speaker. The second talk looks very interesting. So it's using the AI and IoT for the industrial insect farm. The speaker is Dr. Dmitry Mikhaylov. Sorry, I don't know if I pronounce correctly or not. So Dr. Dmitry is the CTO and co-founder of Entomo Ventures, which is a Singapore-registered private company and empowers industrial insect farming through IoT and AI applications. So Dr. Dmitry conducts research in 3 leading universities, including one in China, Huazhong University of Science and Technology in Wuhan, one in Russia, which is the Libdev's Physical Institute, which belongs to the Russia Academy of Science, and also University of Informational Technology in Vietnam, in Ho Chi Minh City, National University of Ho Chi Minh City. He is a guest lecturer in Tufts University in Massachusetts, USA, and also the Belarusian State Universities. He is an author of 5 books and more than 100 publications, and also more than 20 international patents. Let's welcome Dr. Dmitry.
Hello, I hope you can see my screen and
yes,
can hear me very well, right?
Clear.
Okay, great. So thank you for the introduction. I am IoT and AI specialist who ended up in growing insects, and it's amazing. And I've expected this turn in my life. I will not focus any attention on the market growth. We've been speaking about this quite a lot, but with these numbers of growing of all the market alternative protein and waste management, I still I'm not utilizing IoT and AI power and other productions, Entomo Ventures, to make these farms and using AI capabilities fully. A few words about the company. The company itself is established. Research behind this company lasted for about 4 or 5 years in different countries with different universities. We have this great access to academic resources. I will talk about this later. And we are supported by different government associations, different grants, and we are co-founders of AFIA, Asian Food and Feed Insects Association. So, as I mentioned in the head of the small report is that we are focused on IoT and artificial intelligence. See that they are underutilizing what they can do, what they can extract, and almost none of the farms is using artificial intelligence the way it can be used. We work with 3 types of insects: crickets, black soldier fly, and mealworms. And we have so-called triple core.
Hi, Dr. Mitchell. I think the internet is not so good.
Ventures. First step, measurement. I mean that we collect data from different sensors. Yeah. Well, we do analysis. Sorry.
The internet is not very good. Maybe you can try to turn off the audio. Maybe better. Yes, we can hear you. It's quite
okay. Can you hear me now?
Yes. Maybe speak a bit slower. Yes.
Okay. So maybe this will help. So we do measurement, analysis, and control. With control system, by analysis I mean we use artificial intelligence to understand insects' behavior, and we use it to understand also to collect data from external resources like weather, moon cycles, etc. And we also utilize this data to extend type of control, like generate online recommendations for additives for farmers generate control signals to industrial control systems, and of course, ERP inputs. You can see our Entomo Ventures integrated ecosystem on this slide. On the upper level, you can see that we use IoT sensors, environmental data from internet, ERP, and video cameras to collect multiple information. We place it to Entomo Ventures cloud. In this cloud, we analyze this data. This cloud can be installed on the premises of the customer, of the partner, if he's sensitive about his data. And we use this data to send it to farm control dashboard that I will show later, to generate insects feed recipes, and that is the most interesting part, and to control industrial control systems, so-called SCADA systems on the farms. I'll give you several case studies, several examples. For example, you can see sensors here. Simple installation of weather station, monitoring of multi-probes, manual measurements help to reduce human mistakes up to 2 times, and reduce financial losses up to 10 times, just because you reduce the human mistake and you can understand better your insects. For example, most of the insects are very sensitive to weather conditions, and collecting this data from the weather station, analyzing it with the help of AI can help you a lot to improve the farm management system. I'll give you an example from the insects industry. This is how we solved a very simple problem. We installed a small camera over the bin with insects, with crickets in this particular case. And we started to do automatic gender identification to understand the balance between females and males in the bin. That's very important. And to identify sick insects in advance before they start to kill the whole colony. And that alone helped us to reduce losses for one bin significantly with the use just of a small camera. So it's basically, it still is the first system of image recognition for insects. You can see the actual numbers. The death rate before was up to 90% if you recognize an insect, if you recognize a death insect, and after it became up to 60%, so we reduced it by 30%. We use the same approach for black soldier flies. Read their image render from one of the farms. You can see camera here that looks at the bin with black soldier fly or larvae. This is what computer sees behind it. It analyzes the movement of where larvae is, how fast it eats, and or tracks all the activities. And based on these activities, a well-trained neural network can tell you a lot on how to change your process, how to improve your process, which additives to add to facilitate the VCR, and what you are doing wrong. The same is applicable for mealworms. You can see here, this manual labor control is outdated. A simple camera over the bin can help you a lot, and can really save you a lot of manpower and money. You can see the dashboard on this screen. It's called an enterprise resource planning dashboard. We install it on each client we have. You can see all the parameters, but you also can see the alarm tray to the right. This is where our system focuses that you're doing something wrong, or something wrong is going in each particular bin, and we can really help you to improve the process. Same can be done on your mobile phone. On a mobile phone, you can install the app and monitor which tray has a problem, and you can really utilize your human power much more efficiently. And here are the numbers. So reduced human mistakes. Before we had 7.4 human mistakes per colony, after just 0.2 per colony. And we reduced more than 10 times the financial losses by just using this ERP that pushes enterprise workers to works on the farm to work in a different way, just because AI system helps them to control all the trace that human being is just simply cannot do. But you can imagine the amount of data on the farm. And the last concept that I guess it's too early, but the industry is coming there, is using digital twins. Digital twin is a virtual model of the farm. It's a very well-recognized methodology in oil and gas. It's where you imitate all the processes, you do modeling and simulation, and why do you need it? If you have different organic waste, or you have different weather, You want to understand how your farm will react. Instead of making experiments and rearranging a whole bunch of processes that is very difficult to fit the current process and to make these changes very, very fast. Of course, it's not a silver bullet. I mean, our technology, this is not that easy to implement. And I'll explain why. Because you need first to collect a lot of data collection data. Then you have to train your system, train your AI, existing AI, and customized product. So it's not to train your system, it has to be on the supercomputer. I mean, the AI, they train it to make all the mathematics for it to access to supercomputers. And we as a company have access to these great supercomputers in Belarus and in China. And we also have access to this great academic research done by AI scientists in these universities to apply to the data we collect. And the last what we do is this QSI methodology. What we do, we generate recipes, the structure activity relationship. That's like react on different components of organic waste and organic components. And when our AI understands that black soldier fly larvae lacks something or is acting not the way it has to act, we add these components that are calculated and generated by AI. I'll give you an example. You can see it here. We place its lab test. We placed larvae our camera to understand the patterns and how it moves. We adjust and understand what components you need to add for better consumption rate. And it's done online. Recipe generated online. You just have to spray it over the bean, and you have much better results. We made this experiment and tested this experiment on the premises of the Bandung University in Indonesia. Basically, the best, as I understand, the best so far existing test ground, academic test ground, and you can see the actual results of the black soldier fly, increase in larvae weight and larvae length that you can see on the screen, and of course PCR improvement. I understand maybe there are some problems with my connection, but I hope you could hear well. Ready to answer your questions. Hello?
Yeah. Is it?
Hello?
Have your presentation finished? Hello? Can you hear me?
Hello? Yes. I guess you didn't hear much of that, right? Yes.
Okay.
Yes, I'm on. Yeah.
Okay, we have a question from Thomas. Thomas asks, according to the 3 species you are studying, which parameters are the key for AI design farm? Is there a network with the traditional farming to collect data to train AI digital twin? how about the other species like bees? There's 3 questions. You can look at the Q&A part. Hello, Dr. Dmitry. Are you there?
Yeah, basically, let me explain. Yes, 3 species. There are several for each species. There are several parameters. There are several parameters that are important for each species. For example, for crickets, you need to collect sound and picture. For black soldier fly, just the movement is enough. And of course, a lot of parameters from sensors. Depends. Answering your question, it depends on the species type.